to do is to write the molecular formula of pentane. You write the molecular formula of pentane. Then pentane is the 5th member. Number 5 member of what? Of alkane. It is under alkane because it ends with what? With A. The name ending is A. Then you can see alkanes. These are the what? Members of alkane. The 4th member is butane. Then the 5th member will be what? Will be pentane. So pentane is the 5th member, number 5 member of what? Of alkane. So this is the general formula. CnH2n+2 is the general formula for alkane members. So you can derive the molecular formula for pentane from this general formula. Pentane being the 5th member, so your N will be equal to what? Will be equal to 5, since it is the 5th member. Now let's derive the molecular formula for pentane. Pentane, so our N will be 5. C times 5 will give us C5. 2 times 5, that is 10. 10 plus 2 will give us 12. H12. So the molecular formula for pentane is C5H12. That is the first thing. The same molecular formula but different structural formulae. Then what are the possible isomers? What are the possible isomers of pentane? Then the possible isomers means that what are the possible structures that we can derive from pentane? What are the possible structures that we can derive from pentane? So use this formula. You can use this formula to get the possible number of isomers. Use 2 raised to power n minus 4 plus 1. So this one will guide you to know the number of possible isomers that you are going to what? That you'll be able to derive from pentane. Your N is the number of carbon. N is the number of carbon atom. So we have what? 5 carbon atoms. Our N will be what? Will be equal to 5. That will be 2 raised to power 5 minus 4 plus 1. 2 raised to power 5 minus 4 will give us 1. That will be 2 raised to power 1. Then plus 1. 2 raised to power 1 equal to 2. So 2 plus 1 will be equal to 3. So it shows that we'll be able to derive what? 3 possible structures from the molecular formula of what? Of pentane. We'll be able to derive 3 possible structures from the molecular formula of pentane. So we have 3 possible isomers. We have 3 possible isomers. Then what will be the first structure? Because our pattern says that draw and name the what? The structures of the possible structures of what? Of pentane. Draw and name the possible structures of what? Isomers of pentane. So we have 3 possible isomers. So the first structure will be the normal structure of pentane. The first one will be the normal structure. Then we have 5 carbon atoms. So those 5 carbon atoms will be joined together by chemical bond. So we have 1, 2, 3, 4, 5. Then don't forget that in organic chemistry, each carbon atom must be surrounded with 4 chemical bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then you fill with hydrogen atoms. We have 12 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the first what? The first isomer. This is the first isomer, which is the normal what? The normal structure of pentane. So we are still going to call it pentane. Now, to derive the second isomer, we are going to be able to draw what? 3 possible isomers. So to derive the second isomer, you are going to displace 1 carbon atom. You remove 1 carbon atom. So when you remove that 1 carbon atom, the rule is that you are going to place it on what? On any of the remaining carbon atoms. But you must not place it on the first carbon atom at the right. You must not place it on the first carbon atom at the left. So let's remove this carbon atom. It will go with 3 hydrogen atoms, 1, 2, 3. So it shows that you remove CH3. Now, it will remain how many carbon atoms on ground? 1, 2, 3, 4. So we are left with what? 4 carbon atoms. 1, 2, 3, 4. So this CH3 that you remove, you must not place it on the first carbon atom at the right. You must not place it on the first carbon atom at the left. So we have two options. These 2 carbon atoms are the middle. So you can place it here. CH3. Then if you like, you can also place it here. So when you place it on this second carbon atom, first name your structure. So let's name the structure formed. Now we fill with what? Fill with hydrogen atoms. So we fill with hydrogen atoms. So we are going to name this structure now. Now to name what? To name organic structure, you have to what? You consider the longest continuous carbon chain. You are going to select the longest continuous carbon chain. Now let's select the longest chain. So when carbon join with carbon atoms, we call it what? A chain. 1, 2, 3, 4. This is a chain. 1, 2, 3. This is another chain. So we select the longest. We select the longest. So this is the longest on a straight line. 1, 2, 3, 4. So the longest chain will be our root hydrocarbon. It will be our root hydrocarbon. So this CH3 attached to one of these what? Of these carbon atom. The CH3 attached to one of these carbon atoms. Now, the CH3 is on the second carbon atom. It's attached to the second carbon atom. 1, 2. Now, CH3 is called Met-C. It is called Met-C. Met-C is an alkyl group. Met-C is an alkyl group, so we call it Met-C. So this Met-C is on the second carbon atom. So you call it 2-methyl. 2-methyl, because this Met-C is on the second carbon atom. So 2-methyl what? Then you name your what? Your root hydrocarbon, which is the longest continuous carbon chain. So let's look at it. 1, 2, 3, 4. We have 4 carbon atoms. So that will be the 4th member. Number 4 member of what? Of alkane, which is butane. So our root hydrocarbon is butane. So that is the name of the what? Of the second isomer. So we have derived the second isomer. Then, according to this formula, it says that we'll be able to what? Derive 3 possible isomers. So let's derive the third one. Let's derive the third one. So what you are going to do now, you are going to displace another carbon atom. You are going to displace another carbon atom. So you place it on what? On the remaining carbon atoms, but it must not be on the first carbon atom at the right. It must not be on the first carbon atom at the left. Now, let's look at this one. If I displace this first carbon atom, this one will be my first carbon atom at the right. Then you must not have what? An alkyl group, which is Met-C, on the first carbon atom at the right. You must not have it on the first carbon atom at the left. So if I displace this CH3, this one will be the first carbon atom at the right, and we have CH3 on it. So I'm not going to displace this one because this one will be the first carbon atom. Now let's come to this side. If I displace this CH3, so this one will be the first carbon atom at the right or at the left. This one is the first carbon atom at the right. Now let's bring it down. When you remove this CH3, 1 carbon atom with 3 hydrogen atoms. So when you remove this CH3, you'll be left with 1, 2, 3. 1, 2, 3. Then on this second carbon atom, 1, 2, we have CH3 there. Then we have removed this CH3. So you are going to place it on what? On one of these carbon atoms. But it must not be on the first carbon atom at the right. It must not be on the first carbon atom at the left. Then the only option is the one at the middle. So the CH3 that we remove here, we place it on this second carbon atom. Then we are going to name. Let's surround with hydrogen first. So we have derived our third isomer. So we are going to name this third isomer. We select the longest continuous carbon chain. 1, 2, 3. This is 1. 1, 2, 3. This is another one. 1, 2, 3. This is another one. Since we have one on a straight line, so the best is to pick the one on a straight line. Then you number 1, 2, 3. Then CH3 and CH3 are substituents. They are substituents. Why? Because they attach to what? One of the carbon atom on a straight line. That is the root hydrocarbons. So now we are going to name this CH3. CH3 is called Met-C. CH3 is called Met-C. Then we have another Met-C up. So you are going to name the position of the two Met-C. The first Met-C is on the second carbon atom. This CH3 is on the second carbon atom. You call it 2, comma. Then we have another Met-C, still on the second carbon atom. So another 2 for that. How many Met-C? 2. When you have 2, you call it di. 2 means di, so dimethyl. Dimethyl what? Dimethyl what? Then you name your root hydrocarbon. You name your root hydrocarbon. 1, 2, 3. We have 3 carbon atoms. That will be the third member of what? Of alkane, which is propane. Propane. Now, let's see, maybe it goes with what? The definition of isomerism. Isomerism is the occurrence of 2 or more compounds with the same molecular formula. Now, let's check these structures if they have the same molecular formulas. Now, we have how many carbon atoms here? 1, 2, 3, 4, 5. C5. Then how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogen. Now let's check the second structure. Let's check the second structure. How many carbon atoms? 1, 2, 3, 4, 5. C5. How many hydrogen atoms? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 3 will give us 12. H12. So they have the same what? The same molecular formula but different structures. Different structures. Let's check the third one. How many carbon atoms? 1, 2, 3, 4, 5. C5. How many hydrogen? 1, 2, 3. 3 plus 3, that is 6. 7, 8, 9. 9 plus 3 will give us 12. H12. So they have the same molecular formulas, but different structural formulae. So these are the possible isomers of what? Of pentane.